The dopaminergic system in the brain consists of several key pathways, each with specific functions and anatomical routes. These pathways play crucial roles in movement, motivation, reward, and the regulation of various endocrine processes. The mesolimbic pathway. Anatomy. The mesolimbic pathway originates in the ventral tegmental area, located in the midbrain and projects to various limbic structures, including the nucleus accumbens, part of the ventral striatum. Function. This pathway is associated with the reward system of the brain, playing a crucial role in the feeling of pleasure, reinforcement, and motivation. It is also involved in addiction and the generation of the euphoric components of drugs. In the mesolimbic pathway, the blockade of dopamine by antipsychotics reduces positive symptoms of schizophrenia, such as hallucinations and delusions, thus exerting their therapeutic effect. The mesocortical pathway. Anatomy. Like the mesolimbic pathway, it originates in the ventral tegmental area, but projects to the cerebral cortex, particularly the prefrontal cortex. Function. This pathway is involved in cognition and executive functions, such as decision-making. Dysfunctions in this pathway are associated with the negative symptoms of schizophrenia, such as apathy, difficulty in speaking, and lack of motivation. In the mesocortical pathway, blocking dopamine by antipsychotics can thus inadvertently worsen negative symptoms of schizophrenia. The nigrostriatal pathway. Anatomy. The nigrostriatal pathway starts from the substantia nigra pars compacta in the midbrain and extends to the dorsal striatum, which includes the caudate nucleus and the putamen. Function. This pathway is crucial for the regulation of movement and coordination. Dysfunctions here, such as the loss of dopaminergic neurons, are a hallmark of Parkinson's disease, leading to symptoms like tremors, stiffness, and difficulty with movement. In the nigrostriatal pathway, dopamine blockade by antipsychotics is responsible for extrapyramidal side effects, such as dystonia, akathisia, Parkinsonism, and tardive dyskinesia. The tuberine-fundibular pathway. Anatomy. It originates in the hypothalamus and projects to the pituitary gland, specifically targeting the pituitary stalk. Function. This pathway plays a key role in regulating the secretion of prolactin from the anterior pituitary gland. Dopamine acts as a prolactin inhibiting factor. Thus, disruptions in this pathway can lead to high levels of prolactin. In the tuberine-fundibular pathway, the blockade of dopamine leads to increased prolactin levels, resulting in side effects like galactorrhea, gynecomastia, and sexual dysfunction. In summary, while antipsychotics are indispensable in managing psychosis primarily through their action on the mesolimbic pathway, their impact on other dopaminergic pathways can lead to a spectrum of side effects. These effects range from movement disorders due to the impact on the nigrostriatal pathway, potential worsening of negative symptoms, or cognitive effects due to actions on the mesocortical pathway, to endocrine disturbances from their effects on the tuberine-fundibular pathway.